Good evening, my students. My name is Mr. Nyaga, still your physics teacher and also your physics mentor. Today I will continue the topic on floating and sinking. That is our topic in Form 4. And we shall be looking at the law of rotation. On our previous lesson, we learned about the Archimedes principle, and today I want us to learn about the law of rotation, which is a special principle, a special type of Archimedes principle. Now, this law, student, it states that a floating object displaces its own weight. A floating object displaces its own weight in the liquid in which it floats. So we have this statement, and this is our law of flotation, which we are saying it is a special type of Archimedes principle. A floating object displaces, so the object must be floating. It is displacing its own weight in the liquid in which it floats. Let's take a case whereby you take an object, then you immerse it in water such that it is floating. That object, it will displace a liquid, and the weight of that liquid which is displaced is equal to the weight of that floating object. So that is the law of flotation. Now, we can see it is a special type of Archimedes principle, and I want us, we have some questions which will guide us or which will assist us in understanding more about this law of flotation. So let's have a look at this question. So we have the figure of the law. Right to these students, the figure of the law. The figure of the law. So I read for you so that you write. The figure below shows a test tube. The figure below shows a test tube. Whose cross-sectional area is 2 centimeters cubed. The figure below shows a test tube whose cross-sectional area is 2 cubic centimeters. Cross-sectional area is 2 cubic centimeters. Partially filled with lead shots. Floating vertically in water. Partially filled with lead shots, floating vertically in water. So let's have that diagram and have a look at these questions. So we have our test tube here, which is partially filled with some lead shots. So you can draw with me. Then it is floating on the liquid. So this is our liquid. And inside this test tube, we have some lead shots. So we can name these lead shots. We have a liquid here, and this is the test tube. Let's move on. And the height at which this test tube is floating is 5 centimeters. This is 5 centimeters. And this liquid is water. We are told that the cross-sectional area is 2 centimeters cubed. Now let's have the question. You're supposed to determine number 1, volume of the water displaced. Volume of the water displaced. Now student, we know that when we have an object which is immersed in a liquid, it displaces water or liquid which is equal to the volume of that part which is immersed in that liquid. So therefore, let's calculate the water which is displaced, which will be equal to the volume of this part. We have this part which is immersed, which is floating in that water, will be equal to the volume of the water displaced. Therefore, we know that volume is given by, cross-sectional area times what? Multiplied by height. So cross-sectional area times height. And in our question, we were told that the cross-sectional area of this test tube is 2 cubic centimeters. And we have the height. This is the height, which is floating on water. So therefore, what will be the volume? It will be the cross-sectional area, which is 2 times. What is the height which is floating? 5 centimeters. So times 5. So therefore, our volume of the water displaced will be 10. 2 times 5, which is 10 cubic centimeters. So that is the volume of the water which is displaced. Now, our second question, Roman 2, we are supposed to determine the weight of the water displaced. We are supposed to determine the volume of the water displaced. So, write question number 2, we determine weight of the water displaced. Weight of the water displaced. Now students, we know that weight, from this formula we had initially seen that weight is given by density, volume times G. We had derived that in our previous lesson. So if you have not looked at that, you can visit that. So therefore, we have already calculated the volume of the water which is displaced in our Roman 1 question. And we had seen that the volume of the water displaced is 10. And we have the density. This is the water. And we know that the density of water is 1 gram per cubic centimeter. That is the density of water. So therefore, to get the weight of the water displaced, we say it is given by density times the volume of that water times the gravitational acceleration, which is 10. So therefore, the density of this liquid, since it is water, it is 1, but we can convert this into kilogram per cubic meter, and convert this grams to gram per cubic centimeter to kilograms to per cubic meter, we multiply by 1,000. So therefore, we can say this is the same as 1,000 kilograms per cubic meter times the volume of the water displaced. We said it is 10. So 10, change that into cubic meter. So times 10 raised to power negative 6 times 10. So this is the volume, the weight of the water displaced. And if you can use your calculator to calculate that, you see that you will get 0.1 Newton. So this is the weight of the water which is displaced when this test tube is floating in this water. Now student, our third question is telling us to state the combined weight of the test tube and the lead shots. From the law of rotation, we have said the weight of the water which is displaced is equal to the weight of the content which is floating. So therefore, the answer in Roman 2 is the same as the answer in Roman 3 because they have the same weight. So it is 0.1 newtons. That is our answer in Roman 2 because the weight of that content is equal to the weight of the water which is displaced. Now I want a student, you try this question, just write the question. You determine the length of the test tube that will be submerged in a liquid of density 0.8, the same the same liquid, the same test tube with the same content. You determine what would be the length if we used a liquid of 0.8 instead of water. So try that question, and thank you for listening to my lesson.